Good afternoon, everybody. Good evening in Europe. Good night in Australia. My name is Adi Palti. I'm the co-chairman of the ICOI. You don't have to worry. I'm not going to talk about 3D printing. I will introduce tonight our speaker. Dr. Ferguson is going to talk about in-office 3D printing of surgical guides for accuracy and efficiency. Dr. Ferguson has been involved in teaching in implant dentistry over the last 26 years and has lectured nationally and internationally. The lecture topics have included treatment planning, case selection, simple and complex surgical placement and restorations, advanced bone grafting, bone graft materials, use of computer tomography and surgical guide, hygienic maintenance, management of complication and failure. Dr. Ferguson has been instrumental in bringing low-cost 3D printing technology to dentistry and developing digital workflow. He has a private practice in Florida with his wife, Catherine Ferguson, in Davie, Florida. He is an adjunct professor at the University of Florida, and they offered a training course including 6 months live surgery implant continuum. And I can tell you just one secret: when I have a 3D question about materials, printers, everything else, he's the right person, because he's not only involved in theoretical stuff. I have the feeling that everything he will teach us today, he's doing it on a daily basis. So Rick, you're very welcome. He's a part of the ICOI digital leading team. And we are very thankful for you giving us a little bit of from your time. And I'm excited to listen to your lecture. Rick, the audience is yours. And everybody, thank you for reaching this meeting, this online meeting. It will be a continuum from ICOI side. And I want to thank Tara and Ale for putting this together. Rick, enjoy.
Okay, well, thank you, Dr. Palti. I have to say that I'm honored to present for the ICOI. The ICOI has a very special place in my heart. When I first started in implant dentistry, I started with the ICOI. I received my fellowship in 1997. So I go quite a bit of ways back with the ICOI. And I'm glad that Dr. Palti is now involved in taking ICOI to the next level. I think what my topic today is very important for modern day implant dentistry. And it is my goal to share some of what I'm doing in our private practice on a daily basis, as Dr. Palti said. And hopefully you will see the value of what we're doing with 3D printing in the office. So first of all, let me say that I have no commercial interests and nobody has provided financial support for this presentation. I am a key opinion leader for CareStream Dental and for Formlabs. And my wife and I, Dr. Kathy Ferguson, are founders and owners of Digital Educators and Implant Educators Academy, which teach courses on implantology as well as digital dentistry and digital implantology. So a lot of what I'm going to be discussing today actually can be found in an article that I just published in this month's edition of the compendium called Simplifying Full Art Treatment with In-House Printed Surgical Guides and Immediate Fixed Provisional Prosthesis Using Only CBCT Data. Now that is just one aspect of how we're doing surgical guides. But I encourage everybody to go and read this article. You can register on the compendium website. It's free to register, and then you can see the article. And a lot of, like I said, what I'm going to be showing today is discussed in further detail in this article. That said, what I do on a clinical basis daily is dentistry. My wife, Dr. Catherine Ferguson, and I have a small private practice near Fort Lauderdale, Florida. And we have in this practice the technology we need to do some pretty remarkable things in dentistry today. We have CBCT, we have intraoral scanners, and we have a mill to make crowns as well. So what you see here on the screen is our small 3D printing lab that we put in several years ago when we saw the need to bring 3D printing in office. And these are some of the printers, and what you see on the right-hand side are some of the appliances that we will fabricate for our surgical cases. Now, it's important to understand that we are now about 20 years into using CBCTs and surgical guides. And, you know, one of my mentors, Dr. Scott Gans, who is, you know, published on this many years ago. And, you know, I've followed his work for many decades now. And a lot of what we do today, you know, was founded in the basis of what Dr. Gans and others taught us many years ago. But why not do all cases with guides? You know, we're 20 years in, and I know the majority of dentists are still doing cases freehand. Well, of course, there's the cost of the guide, the cost of the software, the lab time, the inconvenience of having cases sent out to have guides fabricated, etc. Given all of these roadblocks, it's not surprising that most of the dentists out there are still doing cases freehand. Now, with affordable 3D imaging, CBCT and intraoral scan, and low-cost smart software that's available now, is combined with in-office 3D printing, we can now change that paradigm, and we're doing about 95% of our cases using surgical guides. We are more efficient. We're able to save money because we're saving chair time, and we're more accurate with our implant placement. Now, when I speak, I usually talk about how we incorporate technology. And what that means is developing workflows so that everyone in the practice understands how you're going to do things. And a lot of what we do in our practice is actually delegated to our assistant. When you're learning new things, it's great. You'll be wanting to do most of it yourself so you can learn. But then you reach a point where you have to delegate it because it becomes work, it becomes production. So I'll always talk about different workflows and how we do things. So the basic workflows you see on the screen here, you have to have a jaw scan with a CBCT machine. And typically we'll do some sort of prosthetic scan or digital wax up because everything we do is based on the prosthetic outcome. So we create STL files of the objective as far as the prosthetic outcome, and then we plan the cases based on that. Of course, we have to have an intraoral scan or some sort of defined scan on which to create a guide. But once those two images are merged together, we can plan our implants, draw our curve to create a surgical guide, and 3D print that guide. Now, it's all about digitizing the patient. So a few years ago, I created a slide to show how we can take the CBCT image and merge it to either an intraoral scan, a stone model that we can scan into CBCT, or a VPS impression that we can also scan into CBCT. So if you have an intraoral scan, absolutely you're going to want to use that. But if you don't have one, you can create a similar image from either a stone model or a CBCT image of a VPS impression. So there are different ways of capturing the data and digitizing the information for our planning. In 2016, I posted a video on YouTube on how to take a CBCT scan of a VPS impression and invert it into a positive model, which gives us our defined scan. And you'll see in a few minutes how this is important, not just for people who don't have an intraoral scanner, but also in cases where you have a lot of X-ray scatter, where there's a lot of zirconia or metal crowns in the mouth. This is a technique that we still use even though we have intraoral scanners. So by merging these images together, the CBCT with one of or two of the images from the intraoral scan or a stone model or VPS, we get the data we need to create a surgical guide. Now, I like to look for open platform systems because that certainly helps bring the cost down for doing these procedures and these these techniques. So when you're looking for intraoral scans, intraoral scanners or CBCTs, it's not that important that you buy from the same company, although you'll see in a minute how that can help make the system faster or the process faster. But it's not critical that you use the same branded instruments. That's why everything that I teach is based on an open platform system. So again, a CBCT plus an intraoral scan or a stone model or VPS of the put in a CBCT machine and scan, and then converted into a positive model from the negative impression. And this can all be done in the software today. When I posted that YouTube video in 2016 on how to invert the VPS impression, most systems didn't have that available, most implant planning software, but now it is, they have evolved as well to incorporate these techniques. So a lot of the CBCT machines have also evolved to include object scanning modes. So you can put a stone model or VPS impression or a denture into the machine, and the machine will have settings that automatically correct for the density of the model or the object, and then give you the proper conversion into an STL file or a CBCT DICOM image. So we can take a stone model, for example, and create an image like this, which is great if you don't have an intraoral scanner. And you can do a similar thing with the VPS impression. I'll show you a video how we do that in a minute. But the object of all of this is to create a surgical guide that then we can print in-house using a 3D printer. And that brings us to the next slide. So there are a variety of 3D printers out there. There are dedicated dental 3D printers. There are consumer level 3D printers. And you know, what you decide to get is going to be based on your needs, whether you're a tinkerer, whether you are willing to put some time into it to learn the process. You can go with a lower cost 3D printer, or if you're the type of person or practice that needs a lot of support from a dental manufacturer. So what you see on the screen here is the Asiga Max printer. It's a great printer. I don't happen to have one, but this is currently a very popular printer in the dental field. And it comes with really good support. It's a very reliable printer. But the lowest cost one that you see here is going to be $11,000. And what you're getting for that is a build platform of 67 millimeters by 75 millimeters by 119 millimeters. And the resolution as far as the XY accuracy on it is going to be 67 micron. Now, all of the printers that we were going to talk about can go down to about 0.25 or 0.2 millimeters accuracy on the Z-axis. So they're all accurate enough to do pretty much anything in dentistry. But on the X and Y is where you get your accuracy as far as the resolution. That's what you should be thinking about, because on the Z-axis, they all have a much higher resolution. So this slide shows our evolution in our practice of the different types of 3D printers that we have been using over the last 5 or 6 years. So in 2015, I decided to enter the world of 3D printing, and I spent some time studying it. And I realized that I could get a 3D printer for about $1,500, which was pretty low at the time. It was an FDM's type of 3D printer, a lot of moving parts, you know, sort of a quirky machine. But I actually brought this to dentistry to use for making surgical guides, and we figured out we could get pretty accurate surgical guides with it. And that was the first 3D printer. That's the blue one you see on the upper left-hand side. And eventually we moved on to the Formlabs printers. We moved on to some cheaper consumer level printers. And right now we are using the Form 3B printer, which is the one up here that you see for about $3,500. And the Sonic Mini, which is a consumer level printer, but actually has a very good resolution. As a matter of fact, The Sonic Mini has a resolution very similar to the Sega printer, a 67.8 by 120 by 120 build platform size and 62 micron resolution. There is a more robust version of that printer, which is the Sonic the Frozen Sonic, not the mini version, which gives you a little bit taller build size and the same resolution, but the electronics in it are a little bit more sturdy and more reliable. So they do have it's not a dental dedicated printer. Neither of these two printers are. And then we're also using the Form 3B, which if you buy it in a dental package, you're going to be spending about $5,000, which is still very reasonable for what you're getting. This is probably the most reliable printer we've had, the easiest to use. And when it's easy to use, that means it's the most delegable as well. It uses a cartridge system. It's somewhat of a closed system because you have to use the Formlab resins, but they use cartridges, kind of like your inkjet printer. It keeps track of the amount of resin, it keeps track of the prints, and it will warn you, for example, if you don't have enough resin in the printer to complete your print. So this is sort of the foolproof. A lot of people say it's sort of like the Apple of 3D printers. And the build platform on it is significantly larger than the other two printers at 145 by 145 by 175 millimeters. Although the micron resolution on the X and Y is a little bit lower, it's still quite accurate enough to do pretty much anything in dentistry. As a matter of fact, the Form 3B printer, which is their dental version of the printer, we can print a whole build platform of models because we also use it to do aligner, clear aligner cases, which we do fabricate in-house as well at a significant cost savings. But this is the workhorse printer that we use for these types of appliances when we're doing a lot of models at one time. Whereas the other two printers are really more for making one thing at a time, such as a surgical guide or a temporary hybrid. Although we are printing surgical guides and temporary hybrids with the Formlabs printers as well. So as far as 3D printing goes, this is basically what you see on the screen here is how a 3D printer works. There's a vat of resin, liquid resin, and there's a build platform that moves up and down, and there's a laser or an LCD light that shines from below and cures layers of material. And then when the print is done, the build platform lifts out of the resin vat. So what you'll see is that the resin, the prints come out wet with resin on them, and you have to go through a washing stage where you either wash the entire build platform, or in most cases, you remove the printed model from the build platform and wash in isopropyl alcohol. And the system we use for that is also a Formlab system. It's the Form Wash. It's an automated system. That's what's nice about it. You can wash in just a simple Tupperware container and using 99% isopropyl alcohol, but that's how you get the extra liquid resin, the uncured resin off of the model. What's nice about a system like the Form Wash is that it dries, not just washes, but it also dries the models. So you never have to actually touch the wet model, which you would need to put on gloves for. But once the system washes, it automatically raises the platform out of the tank and then it air dries. So this is, again, one of the most delegable systems out there because it's really just you put the platform in and press a button and walk away. And our assistants are the ones who are doing these processes typically. So what you see on the right side of the screen here is the Form Wash. And then there's also a curing process after you wash and dry the model. There's a curing process, which depending on the type of resin you're using, you might need to cure for just a few minutes or up to an hour for some of the biocompatible materials. But this is the curing process for example, a temporary crown. Now the temporary crowns with the Formlab systems would need actually two cures. You would cure the model first and remove the support structures, sort of the sprues for you're using an old term in dentistry. And then you do a second cure. But most resins, you just do a one-time cure, especially like things like surgical guides. So you take the model out of the wash and dry chamber, put it in the curing chamber, and cure it for 30 or 40 minutes, depending on the manufacturer's recommendations. And it's important that you follow the manufacturer recommendations so that you achieve true biocompatibility for resins that are going to be used intraorally. So this is a surgical guide, for example. You can see, again, it has the sprues or the support structures. They need to be removed. Depending on how thick they are, different resins require different thicknesses of support structures. And again, a system like the Formlabs, that's all worked out by the engineers at the company, so you don't have to think about that too much. Although we teach in our courses how to use the proper support so that you get accurate prints. And of course, with a surgical guide, then you'd need to put in, depending on the system you're using, a metal sleeve to finish the surgical guide. And you can see that this particular resin has an orange color. The orange color indicates that it has been cured long enough to achieve biocompatibility according to the manufacturer's recommendations and can be used safely in the mouth as a surgical guide. Now, the Formlabs line of printers is great. It's the most reliable printers we found, and we use them on a daily basis. But even a $300 printer like the Frozen Sonic Mini, which is available worldwide and is an open printer, that means you can use pretty much any 405 nanometer compatible resin. You can get, this printer can still print accurately enough to do things like make a temporary hybrid. And you can see here how we printed a temporary hybrid with the Frozen Sonic Mini and how the tie bases drop in. And also it fits in the mouth or on a model very accurately. One thing to keep in mind, though, is that this particular resin that you're going to be using to do these types of things does require very precise settings. So, and that also goes for the orientation of the model in the software before you send it to the 3D printer. So what we found is printing these types of models horizontally gives us the best accuracy on this particular printer. Now, some printers you can print vertically and get the same level of accuracy, but for this particular low-cost printer, it's important to make sure you're printing horizontally with this particular type of resin. And each resin, though, is a little bit different. So make sure that you are following up and checking the accuracy. And this is the NextDent multi-filled hybrid composite resin, which we're using for temporary hybrids, immediate load. And we found that this particular resin needs to be printed horizontally, but you can see how, here we have an accurate stone model and how it fits perfectly on that stone model. All right. If we look at different materials, for example, again, going back to the temporary hybrids, which we're doing immediate load cases with, the typical materials that were being used for this or are being used for this predominantly are PMMA materials, CAD/CAM mill PMMAs. And this article published in 2019 shows you the different flexural strengths of the different types of PMMAs. There's not just one type of PMMA, but they're ranging from 66 to 131 MPa as far as the flexural strength. So now we have actually resins that are printable that are coming close to that range, such as the NextDent C and Crown and Bridge MFH, which has about 107. So strong enough to replace some of the PMMA materials that we're using today. And of course, again, going back to the Formlabs printer, they have recently released a nice strong temporary that's indicated for long-term use. We are sort of using this off-label right now for temporary hybrids because the manufacturer's indications are for 12 months of use and 7-unit bridges. We're making them, we're making temporary hybrids out of these, which tend to be thicker anyways, so they are strong enough, but they are the material is indicated for long-term use in the mouth. And if we look at the information from the manufacturer again, we see that, again, the flexural strength post-cured, giving after it gets a final cure, is over 100 MPa. So again, strong enough for temporary hybrids. And they do also have a permanent crown resin, which is significantly more expensive, but that goes up to 116 MPa as far as the flexural strength. What's nice about the Formlabs resins compared to the next-gen MFH in particular is that it is actually a harder material, so there's less wear. I think, we don't have long-term studies, of course, but just cutting the material with a burr, I found that the Formlabs resins, which are actually made by a company out of Germany called Bigo, this material I found to be much harder and a little bit more aesthetic than the next-gen MFH, which we have been using for several years now for temporary hybrids. And of course, all of these materials are printed in one color. So we do add composite materials, and the material we're using in our practice, there are several companies that make these products, but the one we're using is an axe gum pink composite. We're using that to layer on a layer of composite and then characterize it so that we get the final product that looks like this. Now, our assistants are trained to do this. This is actually something we teach in our, when we get back to doing live courses, we'll be teaching, although we teach this in our online course as well. The idea is that, this is something that the assistants can do ahead of time, and it's fairly easy to do. The Naxcom product actually comes with a nice manual, which was written by Christian Coachman on how to achieve good aesthetics with these products. And you can see here, this is a temporary hybrid that my assistant characterized for us. Most of the time what we're doing is we're characterizing it mostly ahead of time. And then during the surgical phase where we're putting in the implants and doing the pickup, there will be a slight amount of characterization that needs to be finished, especially if, as you'll see later, where we have injection holes or where we have holes for picking up the material. And of course, we're trimming them back. It's also important to understand that not all 3D printable materials are the same. And it's important that you use materials that are FDA classified or CE classified, that are safe to use in the mouth. So you can, what we're talking about here are surgical guides, or according to the FDA, are classified as a class 1 material. The temporary hybrids are class 2 or class 2A, which are more for longer term use. But the surgical guides carry the least amount of restrictions as far as classification. So make sure you buy products from dental suppliers for anything that's going in the mouth. Now, when it comes to making models, that's a different story as long as it's not going in the mouth. Like our liner models, for example, we'll use, basic model resins, and they tend to be a lot less expensive than the biocompatible resins. So you'll see, for example, the Nextent or the Formlabs surgical guide resins, their denture resins, their temporary resins are probably 2 to 3 times more expensive than the model resins. And obviously they go through a lot more rigorous testing to warrant that higher cost, okay? So let's get back to the actual process of making a surgical guide. We start with different workflows, and in our practice, we have 4 basic workflows that our assistants understand on how to capture the data to create the surgical guides. So one is a tooth-supported guide in which you'll capture an optical scan and a CBCT image. The second is where we're doing an impression. This is really for people who don't have an intraoral scanner, how you can create the image that you'd get from the intraoral scanner by scanning an impression or a stone model. Workflow number 3 is where even if you have an intraoral scanner, you're not going to be able to merge the CBCT image with the intraoral scan very accurately because of X-ray scatter, meaning that you have a lot of metal or zirconia restorations in the patient's mouth. In this case, you're going to use an impression scan appliance. You're going to create a scan appliance from an impression, which is a technique we use. There are different ways of doing it. You can have a lab fabricate a scan appliance with fiducial markers, but I'll show you an easy way to use what you already have in your practice to do this. And then the workflow number 4 is a fully edentulous situation where you're using the denture, the patient's existing denture, as the scan appliance. Now, of course, you have to make sure that the denture has the proper prosthetic result that you're trying to achieve. And if the denture is not prosthetically and functionally adequate, then it's recommended that you do a new denture before you use their denture as a scan appliance. All right. So as I said, the manufacturers of our equipment, such as our CBCT and intraoral scanners, have started incorporating and automating the processes. This happens to be the system we have in our practice, where the manufacturer of the CBCT has automated the alignment of the intraoral scan with the CBCT image, so that we just have to click, one click, and it will automatically merge the two images together. And then we can click on another button and export it directly out into the implant planning software, in this case, Blue Sky Plan. So that's built into the CareStream workflow. Other systems, you would have to import the CBCT and intraoral scans manually into the software and then merge them. They do have automatic merging as well, but you'd have to import the images manually. But still, it's an open platform system, okay? And the next step, of course, would be to, after the images are brought in, which I'm showing how to do it here with a different CBCT workflow. But after the images are brought in, of course, the video here is sped up. You're going to do a digital wax up, which is typically what we're doing. Even for a single tooth case, we'll typically do a digital wax up because it's just so quick and easy to do. What you're seeing here is a video that I made. It took me about 8 minutes to do the entire process, and I sped up the video here to a little over a minute. So this is about an 8 to 10 minute process to bring in the different data sets and create a surgical guide. You place the implant in the proper position and then create a surgical guide by drawing out where you want the surgical guide to go, and then basically clicking a button to create the surgical guide file. So the last step here you're seeing is how we create that surgical guide. So they're automated systems to bring the data sets in. And then once you brought the data sets in, you can do the rest of it manually. I know some doctors who have trained their assistants to do this part. I still do this part myself, basically because it, like anything else, you learn how to do it quickly. But this is a surgical guide that was created in about 8 to 10 minutes, and now it's ready to be sent to the 3D printer. All right. So that was workflow number 1, where you're merging a DICOM data set from the CBCT with an intraoral scan. Workflow number 3 is where we have a patient that has numerous metal or zirconia crowns, and we're creating a scan appliance. So the way we create a scan appliance is by attaching glass beads to an impression tray, and taking that tray and filling it with VPS impression material and putting it in the patient's mouth, letting it set, and then walking the patient over to the CBCT machine and scanning the patient with the impression in the mouth. And then we scan the impression by itself by taking it out of the mouth and putting it in the CBCT machine. Now remember, this impression has fiducial markers. So we're basically creating 2 DICOM data sets. And once we do that, we can import both of these into the software and align the 2 images or the 2 DICOM sets using the fiducial markers. And just by clicking on corresponding fiducial markers in both images, you can see how we can align, and basically what we have is the impression, the scan of the impression converted to a 3D file, an STL file, that is aligned to the jaw scan at a very low cost, because basically you're using tools that you already have, or materials you already have in your practice. And this is very, very accurate. We use this for all types of cases, such as this one, where you can see the patient has a lot of metal crowns, which would prevent aligning an intraoral scan accurately to the DICOM data set. Okay. Now that you have this impression, you can then use the implant planning software to invert this into a positive model. So again, this video is sped up, but it's just showing you how we're able to do this very quickly. And now we have basically, I call this a digital pour, and this is using the same technique that I posted on YouTube several years ago, back in 2016. But you can see that it's already aligned, because we had aligned the impression and then basically poured it digitally. And now you can plan your implant and create a surgical guide as if it was the same workflow now as workflow number 1. Because once you get the image, the scan appliance aligned and inverted, you can then switch to the same workflow as workflow number 1. Okay. And here is that same guide being used to place the implant. This was for a molar position, and you can see the accuracy. This is a post-op CBCT image showing the accuracy that we can achieve with our in-office surgical guides. Workflow number 4 is a one-click denture guide. This is where you're taking the denture now and using it as a scan appliance. This is actually the easiest technique, because with this technique, you don't actually have to define the outline of the surgical guide, because the software will take the denture and create a surgical guide from it, basically using one click in the software. So again, we're taking the denture, applying fiducial markers to it, scanning it by itself in the CBCT machine, then taking that image and scanning the patient as well with the denture in the mouth, and then converting that denture into a surgical guide. So let's look at some cases now and how we use these different workflows. So this is Kathy. She's 78 years old. She has a terminal dentition. And our goal here is to place implants and give her a fixed prosthesis. So in this particular case, I decided to use the denture approach, workflow number 4. And I also decided to do this case flapless and then let the implants integrate before actually loading them. So I could have loaded them immediately, but in this particular case, for whatever reason, we decided to let the implants integrate first and then go back and uncover them. So what we did here was we took her denture, applied the fiducial markers, and took a scan. And here we're doing upper and lower. So we took one scan with the upper denture and one scan with the lower partial denture with the fiducial markers. It's important to understand if there's metal in the partial, you probably want to remake the partial without any metal. Otherwise, it's going to cause some distortion or scatter on the CBCT image. So once we had these two images merged, we plan out our implants. We convert the denture into the digital version of the denture, not the patient's actual denture, into a file that then gets converted into a surgical guide. So here we are using that surgical guide, which is fixated in place, and it's indexed by the patient biting it to place. So it's important to leave enough teeth on the denture so that we can have the patient bite it to place and then put in fixation pins. That's how we get the accuracy from this type of a guide. So here we are using the guide to place the implants, and we place the implant flapless. This picture shows the implants already in. We basically went right through the tissue and put in 6 implants. Here's a post-op CBCT image. Now those were where the implants were planned, because the implant placement system we use also allows us to control depth using the guide. Here is the case uncovered several months later with our multi-unit abutments in place. And now we decided, we went ahead and did the lower in a similar fashion, placed 5 implants for the lower. And now after those, everything is integrated, we went back and did our final impressions. And what I like to do is use a 3D printed temporary. So this is a temporary that was printed on an older low cost printer. The printer was, I believe, a Photon or Photon S printer, Anycubic Photon. And this was printed with the NextDent MFH resin. We printed upper and lower temporaries to make sure that the function and the aesthetics were good and that the patient accepted what we had created. Sometimes we'll make a second version. If the patient's not happy, we'll go back and change the design until the patient and the clinician also is very happy with the result. And this is what we ended up with. And once that's done, we turn it over. We will actually scan these appliances because typically we're doing some intraoral adjustments. So we'll take them out and scan them with the intraoral scanner to accommodate for those adjustments, and then send that over to the laboratory technician who will design the final prosthesis. In this case, it was Exocad that was used to design the final prosthesis and mill them in zirconia. So Dr. Palti was mentioning earlier before I started the webinar that his practice is metal free. So they're doing this a similar workflow using full arch zirconia with their in-house mill. Now we don't have, we're not doing in-house milling for full arch cases, but we will send the information to the laboratory so that they can do the final restorations. And here is the lower. And here's what it looks like after it's been placed in the mouth and fixated. And here's the patient's final smile. So we're able to achieve these excellent results using our digital workflow at a very low cost, because we're doing some of it. We're making our own surgical guides, which increases our efficiency as far as the surgical placement, as well as working out the temporaries and printing those in-house as well. And what you end up with is a happy patient. All right. So here's the before and after of that case as well. So let's look at an edentulous case, a lower edentulous case. This is Ernie. He's 46 years old and suffered from advanced periodontal disease, and all his teeth had to be removed. And now he has a set of dentures. So we did the denture technique again for him in lower. And in this case, we decided to do immediate load. So what we did here, and you'll see what we're doing, this is a case that's about 2 years old. I actually no longer use this technique because we've evolved, and I'll show you just a case I did just last week, how we've advanced even to do this type of case as well. But this is one of the first cases we did using this technique where we converted the denture into a surgical guide, but also into an immediate load prosthesis based on the patient's existing denture. So in this case, we used a surgical guide to place the implants. You can see how nice and straight everything turned out. We picked up this temporary version of the denture that was printed in NextDent multi-filled hybrid composite resin, and then handed it over to my assistant, who goes ahead and finishes this and characterizes it while I'm closing the case up and suturing. She'll be adding the characterization and filling in any voids, etc. And then we can deliver that as a immediate load prosthesis, which then allows the implants to integrate. And we go back in 4 or 5 months and take this out and make the final zirconia prosthesis. Okay. So how accurate is this type of a guide? Here is the post-op x-ray of the 6 implants placed. And what you see here is an overlay of the pre and post-op. The red is where the implants were planned, and the white is where the implants actually ended up. So I'd say it was a pretty accurate result using our in-office surgical guide, using the patient's denture as, and biting the denture to place as an index. Now, you'll see here that this is an axial view, again, showing the red where the implants ended up. sorry, where the implants were planned in red and where the implants ended up in white. And again, very close to the final result. This is certainly better than doing it freehand. And with our workflow, it's much faster and much more efficient in the clinic. So this is Judy. She's 76 years old, and her requirement was that she did not want to wear a removable appliance. She had a terminal dentition in the maxillary, and what we decided to do here was do an immediate load case as well, because she refused to wear a removable appliance. Now, because she was fairly happy with the aesthetics as far as the shape of the teeth and so on the upper case and the bridge that was failing, we decided to use that as the template for her immediate load prosthesis. So this is her immediate load prosthesis on 6 implants. So here's how we went about the case. We scanned the patient using workflow number 3, which was an impression scan appliance, inverted it and merged it to the CBCT image, made from that a bone reduction guide. So we took out all the teeth, laid a flap, put in our bone reduction guide, and reduced the bone down to the level of the bone reduction guide. We then put on top of that a drilling guide, which was all, again, created in the software that stacked on top of the bone reduction guide. We drilled the osteotomies and placed the implants through this drilling guide. And then once the implants are placed, we took our 3D printed temporary hybrid and put it in over the telescopic copings and injected our pickup material. So here is the bone reduction guide still in place. And I said from the previous case, we have evolved to this type of a workflow where we're not making a full denture as our temporary appliance. What we're doing is just, the denture is basically just a part that fits over the bone reduction guide. So this gives us a little bit more leverage as far as we don't have to lay as big a flap, we don't have to make as big a denture, etc. Or in this case, we didn't have a denture to start with, so we didn't have to actually design a denture. We used the patient's existing dentition from an intraoral scan, which was then aligned to the impression that was inverted. So we will take the denture and try it in first. Of course, some of the copings, typically you have to reduce the height. We'll put some rubber dam over that, and then we will do a pickup in the mouth by injecting material through these pickup holes. And in this case, this is what it looks like after the material set. We've picked up the copings by unscrewing them. Now we can take the whole thing out and hand that over to my assistant, who will finish by filling in any voids, finish the characterization, and have that fully cured so that we can put that back in the mouth. And this is what it looks like going back in, attaching to the implant. So while she is doing that, I will be removing the bone reduction guide and doing the suturing. I'll typically smooth out any sharp edges on the bone, which is typical when you have bone reduction guides. And then this is the final temporary prosthesis in the mouth the day of the surgery. And we leave that in for about 5 months, typically 4 to 5 months. This is what we see after 4 or 5 months with this printed temporary. If the patient is maintaining it properly, of course, you have to leave an adequate space for them to be able to get under it and clean it. But this is basically what it looked like, not being disturbed for 5 months. This is the first time it's been removed for 5 months. And we know, of course, that with cross-arch stabilization, this is the best way to get good integration of your implants and still have immediate loading of the implants. This is the underside of the 3D printed temporary after about 5 months in the mouth. And you can see she did a pretty good job keeping it clean. Of course, when we go over to zirconia as a final, it'll be a lot more hygienic as well. So this is the most recent case that we did using this more improved or updated workflow. And I went one step further in this workflow. This is a lower case, of course, but I went one step further in this workflow, which was instead of using a rubber dam, we created a gasket. So this is Don, 76 years old. He has a failing dentition, high rate of caries, and really was looking for a more permanent solution, than trying to save or restore these teeth. So this is before, and then this is the day of surgery. We did the lower first. So we're doing just the lower in this case. That's typically how we do the cases in our practice. We find that it's a lot less stressful to do one arch at a time. And then once we have one arch, typically the lower established, we can build the occlusion and the opposing to match the lower arch very easily. So typically this is how we're doing the cases, one arch at a time. Of course, we can do it both arches at a time as well, but it means a lot more work and a lot more chair time. And for us, this just happens to work in our practice. But I have trained dentists in these techniques who are doing both arches at a time, and that's fine for their type of practice as well. So this is what we start with. We start with intraoral scans, merge them to the CBCT image. As a matter of fact, this is the workflow number one, just merging intraoral scans to upper and lower CBCT images, designing a denture, planning the implants to that new denture, and then creating a series of surgical guides. In this case, we start off with a pin guide. The pin guide is going to index our fixation pins onto which we are going to put our next guide, which is the bone reduction guide. So the pin guide fits on the teeth. We take out the teeth and then we put in our bone reduction guide. Of course, we have to lay a flap to do this. So this is the bone reduction guide now fixated. It's indexed from the pin guide to keep our accuracy. It also has these straps that go over the top of the ridge. Typically remove the lingual strap. In this case, I left it because it wasn't interfering with the tissue, but if I had to lay a bigger flap to put it in, I would have just removed it, because just the buccal surface and the occlusal wings are enough to stabilize this type of a guide. So we use this bone reduction guide to give us the proper bone reduction so that our next guide, which is a drilling guide, will fit. This guide won't fit unless you do the proper bone reduction. So if you put this in and it's not seating properly, typically it means that the bone reduction is not complete. So the bone reduction guide is actually a very good way to, have an accurate bone reduction, but then you verify it with this drilling guide. So here is the drilling guide being used. And again, with our system, we used a BiHorizons implant system, which has a guided surgery kit, which also allows for guided implant placement to give us the highest level of accuracy. So here we've placed the two distal implants first. And in this particular case, we're placing 5 implants. The 2 distal implants are going to be at a 30-degree angle to match up with 30-degree multi-unit abutments so that everything becomes parallel. The implants in the anterior are typically going to be parallel to each other, if we can get them parallel to each other, depending on the volume of bone we have. And then the distal implants are angled 30 degrees or 17 degrees, depending on what you choose to do based on your existing bone anatomy. And then the final step is to put in the printed temporary hybrid. Now this one was actually printed with the Formlabs temporary resin, which is a very nice aesthetic resin. The picture in the lower left here is how it comes out of the printer. You do have to clean off the ceramic powder after it gets washed. It is a ceramic filled resin, which gives it a very nice hard feel to it. So this is my current preference for doing these in-house on the Formlabs printer. And then this is stacked on top of the same bone reduction guide for the pickup. And I will typically manually drill out these injection holes because I found it easier than trying to design them in the software. But also with this particular process, we've gone from using a rubber dam to creating a gasket, basically a silicone gasket made from the same material you use to do relines on dentures, that is very, very accurate and keeps the hybrid, the temporary hybrid, from getting locked on to the multi-unit abutments when we do the pickup. So the gasket will be placed, the telescopic copings will be placed on the multi-unit abutments, and then the denture will be put in and picked up by injecting into the injection holes while the patient is biting it to place. This is important because this will account for any discrepancies on the occlusion as well. So we'll typically have the patient bite this to place and inject from the lateral aspect and pick that up. And then again, hand that over to the assistant, who will then fill in any voids, make sure there are not any concavities around the multi-unit abutments to capture or hold food and accumulate food and plaque, so that the patient can keep this clean. And then while the assistant is doing that, I will typically take our PRF membranes, which we would have created from the beginning of the procedure. We draw the blood, and using the sewn poncho technique, slip those over the multi-unit abutments and suture. So a very staged approach of, we have this protocol in place that we do the same thing sort of every time, which makes it very efficient in our practice. And then the last step is to take off the multi-unit caps, which we put in place for the suturing, and then screw the temporary hybrid in place. And this is how the patient goes home with the temporary hybrid. And very straightforward surgery, very efficient, because again, everything is planned out ahead of time. There's not much as far as guesswork to be accomplished, chair time. So what we're basically doing with guided surgery is taking that thought process, the decision-making process from all the steps, and moving it to before the surgery. So you are going to spend some time designing the case and planning out the case. But as I said in my article in the compendium, what you should be doing is thinking about the design process, mimicking the stages of the surgery. And that's how I came up with these workflows that seem to work well in our practice. I'll finish up with this one case. This is Rhonda. She's 59 years old, and she has a fractured tooth number 9. She has a purulent discharge coming from the lingual, and this is basically a case where we're going to be doing an immediate placement into a socket. So we decided in this case, because there was a good bulk of the root remaining, that we would do a partial extraction or a socket shield technique. So here is the case being planned, making sure that we have the adequate distances and position of the implant, etc. We tend not to keep a high amount of inventory as far as implants in our practice these days, because we're planning out cases digitally, and then we know exactly what to order for the case, plus or minus a few extras. But this is how we're planning out the implant to be placed in relation to the root of the tooth. So here we go now to the surgery. We will section off the tooth, cut out the majority of the bulk of the root, leaving only a sliver of tooth structure in place. The purpose of this lecture is not to teach you this technique, but to show how we're using surgical guides to enhance the technique and get more accurate placement of our implant. So once the root section is removed, we go ahead and put in our surgical guide, and then use our guided placement as well. So we drill the osteotomy and then place the implant through the guide as well for the highest level of accuracy. So this is an immediate post-op CBCT. You see we have bone just to the palatal of the implant. We have our root shield in place, and then we have a space which we will fill typically with allograft or the patient's own autogenous bone. Once we're happy with the position, and then again, you can see the accuracy. The red is where we planned the implant, and the white is where it actually ended up. So very accurate implant placement compared to the original plan. This was based on a tooth-supported guide, which tends to give you the highest level of accuracy. we will get an Ostel reading on the implant, and if it's high enough, we will put a immediate load temporary crown. In this case, it wasn't. We did not have the highest level of stability, which would be over 70 on the Ostel system. So we decided to put a customized healing collar instead, which we fabricated chairside. And then we add again our sewn poncho technique using a PRF as a biologic seal and tissue enhancer. We put that in place and then basically pack the PRF in between the tissue and the temporary. The temporary, by the way, was made just with flowable composite resin on a stock abutment, metal abutment. That's my preference, is to use a metal abutment for these. So this is what it looks like immediately post-op. And here it is a week later. You can see how nicely the tissues are healing. And then after about 4 or so months of integration, we go back now and make a screw retained temporary crown, which then once we got our tissue heights corrected, we can then scan. And this was done through a total digital process where a zirconia abutment was fabricated by the laboratory from a digital intraoral scan. And then we actually milled the crown, the final crown, in-house. I found that the best way to match an anterior tooth is actually to fabricate in-house. And this crown was made on our mill using Emax. So we can characterize it chairside, and it's somewhat of a long appointment for the patient to sit there while we do this, but it saves multiple appointments. So in the end, it's basically saving you time and aggravation because we are doing this same day. And if we look at the final restoration, how we were able to preserve the tissue contours of the original tooth that was in place. Now we could go back and do a little bit of laser recontouring here to make both of these ideal, that are, an equal shape. But frankly, the patient was very happy with the result. And, I even showed her how the tissue looked exactly like she had on her previous tooth. And she was very happy with the result here. Okay. So that's how we're using in-office surgical guides, not just for full arch cases, but for single tooth cases as well. And as a matter of fact, every case that we do almost in our practice now, about 95% of our cases are being done with surgical guides, because we have the ability to fabricate and use surgical guides for almost every type of case that we've encountered. Okay, so let's finish up now talking about the economics of doing this. Is this going to bring value to your practice? I think it will. If we look at the cost, the ongoing costs of the materials, surgical guides, we're printing these with the design and everything for about $5 to $10. The software costs vary by the software you're gonna use, but with the Blue Sky Plan software, which we're using for the vast majority of our surgical guides, it's about a $15 cost added to this. So you can see, but in the $20 to $25, $30 range, we can create our own surgical guides. Models we're printing for about $1 to $3 a model. And the temporary hybrids, because of the labor involved in the staining and characterization of it, and also the cost of the resin tends to be fairly high. You're looking about 35 to 50 bucks inclusive of labor costs, materials costs to make those as well. Every type of printer is going to use some sort of disposables. So this typically is resin tanks, and some resin tanks there's a film at the bottom of the resin tank that you can change yourself. Those tend to be the lower cost consumer level printers like the Sonic Mini. To change that film is about $5 versus going up to some of the more expensive printers, such as the NextDent 5100 printer, which is a very nice, fast dental printer. The tank there is going to run you about $500. The Formlabs printers, the tank ranges anywhere from $100 to $150, depending on which version of the printer you get. The Form 2 tanks are about $100. The Form 3, the newer version, is about $150. but you're going to get a lot of prints out of those. So those are just some of the disposable costs. And of course, you have to wash these prints in isopropyl alcohol. And although isopropyl alcohol is very expensive right now because of the pandemic, it's still pennies per model when you factor in and extrapolate out on a per model basis. But really, the convenience of being able to do this in-house, to me, is priceless. That last full arch case I showed you, we did that case last Wednesday, and I actually planned the case out the previous Sunday. So I tend to be a procrastinator, and I can get these cases turned around literally within a day, typically, right? You know, and this technology works for me because I am such a procrastinator, actually. But the convenience of being able to turn a case around and knowing that you're able to do that sometimes makes you a procrastinator, but the convenience of it to me is really what makes this priceless. And the fact that I have so much control over the case. I know going in exactly what the different procedures are going. Here's my personal email address. Please don't abuse it, but if you have any questions, please reach out to me. I'll be happy to answer any questions. And then one last thing I'd like to put out there is that I do run a dental 3D printing group, which I'm very proud to say has over 11,000 members worldwide. And it's a really nice collaborative effort where people share information, techniques, settings for a variety of different 3D printers, from the high-end dental printers to low cost, you know, consumer level printers such as a Sonic Mini. And I do post a lot on this page, and I will answer questions typically on this page as well. But we do have several other people and a lot of collaborators on there that maybe has the same issue that you're having or at the same level of learning as you are, and are willing to help out and join. And I'm very proud of this group. In just a couple of years, we've expanded to over 11,000 members in pretty much every country in the world. So with that, I'm going to end the presentation and turn it back over to Dr. Palti. And again, I'd like to thank the ICOI for giving me the opportunity to present and share what we're doing with in-office 3D printing. Dr. Palti.
Thank you, Rick. There are a few questions. And the first question is, how long do you cure NextDent surgical guide?
The NextDent surgical guide resin. Now, keep in mind that it depends on the cure unit you're using. So with the NextDent surgical guide resin, there is a color change. So the resin directly out of the printer will have a yellowish, glowing type of yellowish color. And then once it reaches full cure, it'll turn into an orange-ish type of color. So as you saw in these slides, typically on the form cure machine, we're curing that for about 40 minutes, okay, to achieve that biocompatible stage. Now that's also true for the Formlab surgical guide resin, the original version of it. Formlabs has a new surgical guide resin that is actually clear. So it doesn't necessarily have that color change, but you got to make sure that you follow the manufacturer's recommendations. All right. There's not really a problem with over curing. So if you want to err in the over curing arena, then maybe over cure instead of under cure. Okay. But what I would do is look at the manufacturer's recommendations as far as what they're recommending especially with the biocompatible resins. Okay.
The next question, Rick, is what Convim CT are you using?
Oh, in our practice, we have actually a medium field of view Carestream 8100, which has been a great machine. We've had it for over 4 years now, and I love the image resolution on it. It's got a very high resolution. It's great for looking at fractures or endo issues in teeth as well. But it's just enough to do these full arch guides that I'm doing. And They do have a new version of that machine, which is the 8200, which is a slightly larger field of view. The field of view on the 8100 is a 8x9 8x9 centimeters. The new one, I believe, goes up to 10x12, but don't quote me on that. It's a slightly wider field of view, which is great if you're going to be doing like wisdom teeth, etc. So that's the one we're currently using. And I just love the resolution on it. And the fact that it also works well with our intraoral scanners. We have 3 intraoral scanners in the office. Just because we're doing so much digital dentistry, it became a hassle to move the scanners from room to room. So what we did was a few years ago when they had end of year specials, we bought, more intraoral scanners. And guess what, guys? It's the end of the year. So I'm sure there are a lot of end of year deals right now. And actually, unfortunately, COVID has, brought us to some good deals as well, because obviously the manufacturers are typically not selling as much equipment because of the COVID issue. So take advantage of some of the deals that are out there right now.
So the next question and the deal is, what software are you using? I'm sure there are multiple software which will give a great deal at the end of the year.
Yeah, so we're using primarily Blue Sky Plan, right? That's basically the one that we teach in our courses, but we also do some things with exocad. And we also do use co-diagnostic software, which is from Dental Wings. So I am familiar with planning and designing in all of those softwares. exocad has exoplan, which I personally haven't used to plan implant cases, but we do design of dentures and temporary hybrids in either Blue Sky Plan or in exocad as well. And the final zirconia hybrids are done in exocad. All right, but there's 3Shape. 3Shape also has their own planning software. There's several more out there that I'm not so familiar with. Obviously, you can't learn every software and use every software, but those are the ones that I'm using personally.
And the next question, Rick, is what kind of resin do you use for temporary hybrid immediate loading?
So the temporary hybrid is the NextEnd MFH, which we've used for probably about 3 years now, primarily. And then just more recently, since Formlabs came out with their ceramic filled temporary materials and now their permanent materials, I haven't used a permanent resin yet for temporary hybrids, but I have used the temporary, which is really, really nice. It just feels nice. It's a very hard material, more similar to what we were getting with milled PMMA. Really, if anybody can register on the compendium website and have direct access to the digital article. And so that's what I would recommend people do, because they're actually going to get the full resolution images on their computer screen. So read the article there. And the full article is there, in an actually easier to read format. So you can go on the compendium's website and register for free, and then have access. That actual issue will be, it's the November-December issue. So it will expire, I think, at the end of December. So get on there quickly to do that if you're going to do that. All right. And then they'll have the next issue up probably in the middle of January. So they only post one issue at a time, but while that issue is posted, take advantage now. Okay.
First of all, I want to thank Rick for the fantastic presentation. I can tell you a secret. You want to get some information, go on the Facebook site and he will answer you, which is absolutely correct. So although I don't think Facebook it's the right academy, but this will be the right communication with Rick. So Rick, thank you very much for a fantastic presentation. We look forward to do more activities with you. And thank Tara and Ale for putting this program together. And just follow the emails you will get from the ICOI about our next online lectures. Thank you, Rick. Have a wonderful weekend. And we appreciate very much your support, and we look forward to working with you.
Thank you again, and have a great rest of the weekend, guys. Good evening and good morning and good day.